테이프 있는 대로 옮기면 돼요. 네.
안녕하십니까. 오늘 제6회 글로벌 EV 라운드
Ladies and gentlemen,
제 방성용입니다.
Bang the CEO of Greenerge, and I'll be your engineering director. I'll be your moderator. Today, we are going to first invite the opening remarks by Chairman Park Jong-woo of the Planning Committee of Jeju International Expo. He will deliver welcoming remarks.
I'll take off my mask for a while. Hello, everyone. So, welcome to the 9th International EV Expo. On behalf of the Chairman of the Global EV Association Network, Mr. Dae-Hwan Kim, and the International Electric Vehicle Expo Organization Committee, it is my great pleasure to address the second day's Global EV Roundtable. My name is J.W. Park, and then I organized 6 Global EV Roundtable. Personally, I would like to take this opportunity to thank all of you for participating with us at Global EV Roundtable. Yesterday, there were 2 sessions. First session was autonomous electric ship technology, and the second was future UMA technology. We all realize the electric ship and the UMA technologies have been progressed quite a bit. The sessions are very informative and fruitful discussion. Today is the second day of EV Roundtable. The first topic was today's forum will be focused on future battery technology, organized by Scott Baum, CEO in Greenerge. As you know, the battery technology is one of the most important and essential component for all of the electric-fired transportation. Today, we will learn a lot about future battery technology. The second topic will be focused on strategy of EV charging system business, organized by Ung Chul Choi, professor in Kookmin University. Although fast charging system as it today, one of the hurdles to overcome for future electric transportation, battery charging technology has been developed significantly. Today, we will learn fruitful knowledge and informative discussion for future battery technology and fast charging system business. Welcome again and enjoy the second day of EV Roundtable. Thank you all. 감사합니다.
박정호 위원장님 감사합니다.
Thank you very much. Now I would like to introduce you to the speakers. First, from LPN, we have CEO Jung Young-un. He will talk about development of natural graphite anode for artificial graphite replacement.
반갑습니다. 저 LPN의 정영훈입니다.
Hello, I'm Jung Young-un, the CEO of LPN. Our company, LPN, originally was developing the electronic material, and I have some experience in developing batteries. And based on that experience, we are developing natural graphite anode, and I will share our result with you. We have 54 employees. We have 3 portfolios. The first is to develop high K for electronic products. We are developing and producing precursors, and also we produce OLED materials. And our customers include Seoulbrain and Samsung SDI. Last but not least, we also have anode materials, and we are developing 2 things. For silicon anode, 2 types. And then we are also developing natural graphite that we are developing to replace artificial graphite. As you're well aware, we are entering an age of electric vehicles. Compared to 2020, by 2030, we are going to have 10 times more EVs, and the market will grow by tenfold. And anode materials are also going to increase significantly in terms of market size. And currently, we are focusing on anode material for EVs and improving the lifespan and output for the anode material. And because of that, a lot of artificial graphite is being used, but artificial graphite requires a lot of other industry support. So the cost is very high. So we need to look for environment-friendly and cost-effective replacement for artificial graphite. Let me talk about our graphite anode. We are developing graphite anode in 2 ways. First is to pulverize metal silicon into nano size and create composition like graphite. Based on the technology that we already have, we could use nitrogen in some parts of the anode material, and with the nitrate, we can create SPA surface, and that would change the conductivity of lithium-ion, making it more secure and long-lasting. And the capacity per gram is 1400. We can bring it up, but with 40% silicon, we can achieve between 1400 and 1500 output. And the efficiency is 89%. When you look at the structure, nanosilicon is pulverized into 100 nano, so it's very tricky to handle. So we are using massive core, and on top of that, we are coating the silicon. And we finish that off by isolating with carbon. And with that technology, we can achieve very high performance, but it's very difficult to create nanoparticles, and that requires a lot of capital expenditures. And if we are producing 100 tons, we need 150 to 200 units of this expensive equipment. And I heard that SDI is using this kind of anode produced in this manner. We already have this system in our lab, so we have realized this process. But the capex investment is so huge that it's kind of burdensome. So the second thing we developed was doing it without pulverizing. We have to create nanoparticles of silicon without pulverizing. And then we have developed this technology. When we are cooling this, extremely saturated particle will come up again, and that should be prevented from getting bigger than nano size. And if we can quench at the moment, we can have the nano size without pulverizing. And silicone and alloy can be added and then melted together. And they can be cooled very rapidly. And the silicone will grow into cores, and after it is quenched, it will stop growing. And these black dots are the nanosilicones, usually between 30 nano size, and they are alloy material. In the previous page, you can see silicon has been coated on graphite and carbon isolation. Carbon isolation is a very important step, but without having to do that, we can have the nanosilicon particles surrounding the matrix. So it can be done very fast, and it is produced as a chip. And facility investment is 1/5 the pulverizing facility with 3 times higher productivity. So OEMs or cell makers, their target price for silicon anode material is $30. So with this technology, we can produce at around $20 cost. So compared to CapEx, the CapEx is low, and we can produce a lot, and we can have even smaller than 100 nanoparticles. So if we can finish this technology, it can really be a game changer. And in our test, it has had no problem for small scale. Of course, we need to improve several areas. Depending on the type of alloy, the size of core can be different. So we have to come up with the right ratio of blending between different metals, and quenching conditions should be improved as well. This is the main topic for the day, and we call this natural graphite. Natural graphites are collected in the mines, and they can be processed to be used for batteries. So this is natural graphite. So the capacity is high, and it is cost. But when you look at power cyclability, there are some drawbacks. Compared to that, artificial graphite is based on quartz thermal processing at around 300 degrees Celsius, and the quartz will become crystallized and then turned into artificial graphite. It would have excellent cyclability, power, but the price is high. And for artificial graphite, for 1 ton of production, for 1 month, it needs to be heated up to 300 degrees, so it requires 15,000 kilowatt per ton. When we are collecting this at the mines, it will be processed into spherical graphite, and the yield for spherical graphite is extremely low. Sometimes the yield is just 30%, meaning 70% have to be just thrown away. If we can reduce the level of sphericality, then we can have 40–50% yield, but more than half still is thrown away. So we wanted to use this half of this graphite that is being thrown away and artificial graphite market is growing for EV, and we developed this technology, graphite anode material. When we collect graphite from the mines, it will be discarded as flaky graphite. And while the natural graphite has cost issue due to the low yield in spherically shaping with the flaky graphite, we are doing all this in China, and then we buy that and we do the pivot processing separation process. After spheroidization, using the facility that we developed, we put them into spherical form, and the yield here is 80%. At first, after 4 days of processing, this is what we had for 15%. But the facility that we developed would require 10 minutes of processing, achieving 80% of yield, and the remaining 20 would be either too big or too small, and they will be pulverized again and then recycled. So the usage rate would be 100%. To replace artificial graphite, the natural graphite is processed into small spheres, and that artificial graphites would be amalgamation of cokes and 1 month of thermal treatment at 300,000 degrees Celsius, and it will be turned into graphites. And then with lithium ions, this natural graphite will go through the interqualification, and there will be some stockpiling and bottleneck here. When lithium ion is put in here, this would create extreme stress. For artificial graphite, the structure is short, so there is a lot of pathway for lithium ion to enter, and the distance that needs to be traveled is very short. But in case of our graphite anode, it's just an amalgamation of small structures. But crystal itself is much better. Artificial graphite is being crystallized over a long period of time, and it's difficult to control and fine-tune the microstructure. But if we're going to pulverize one more time, the output would be much higher in our process, and we can also control this and fine-tune this. Natural graphite at first would have high capacity, but it will go down. Artificial graphite also goes down, but our declining rate is much smaller than that of graphite, artificial graphite. And since they are put together, amalgamated together, many people worry that whether this can sustain high pressure. And then we did with 1.5 degrees pressure, and the crystal was still solid. So the properties were really excellent, and when compared to artificial graphite, 0.2 degrees Celsius resilience. This is graphite from GSM, and it's only 83%, but our number was 92%. Full cell test. These are the test conditions. And natural graphite, we used the Nippon lichen from artificial intelligence from lichen. And in 25 degrees, Nippon Chemicals graphite at 700 cycles shows capacity drop. And this is within the deviation. And our anode and artificial graphite show this kind of pattern. After 700 cycles, the capacity retention was 83%, and it was much more stable in higher temperature. And C-rate performance, the pattern is not so obvious, but between green and red lines, compared to the green line, there's a lot of duplication. So we felt confident that we can replace artificial graphite. And capacity recovery, this requires 2 months of 60 degrees Celsius storage. And this shows 60 degrees, 2 months. And the bulging test was lower. The level was lower than artificial graphite. Impedance data, fresh cell, natural graphite showed the lowest number, 45 degrees, 700 cycles. We saw the impedance change, and the spherical graphite had the least change and had the excellent, most best property. Regarding spherical graphite, we have 2 patents already, and for silicon, we have filed for NX technology. Based on that, we are continuously filing for other related patents. If artificial graphite is needed for EVs, then this coax-produced power and coax can be put on surface, 300 degrees, 3,000 degree thermal coating. This creates a lot of environmental pollution. And electricity is always converted to CO2 emission. So artificial graphite is not good for the environment. So by reproducing natural graphite, I am very confident that we'll be able to replace artificial graphite. And we are developing this technology. And this year, we are going to build a pilot plant for 100 tons of production. And in the pilot plant, we want to test and validate and find the factors for automated production. And in the second half of next year, we are going to build mass production for monthly production capacity of 1,000 tons. Thank you very much for your attention. Does anyone have any question for LPN? No, we will move on to the next presentation.
Next presentation will be given by Dr. Jo Myung-dong from Green Energy. The title of the presentation is Solid Polymer Electrolyte for High Energy Density Battery. Hello everyone, I am Jo Myung-dong from Green Energy. The title of my presentation is the project that are going on at the U.S. Research Institute that I work for, and I also would like to share with you our future plans and direction.
죄송합니다. 일단 시작을 하겠습니다. 그러면은.
Let me begin. The title of my presentation is Solid Polymer Electrolyte for High Energy Density. Recently, there are a lot of companies and academic associations and society trying to find a way to come up with a solid polymer electrolyte. And also, it's been more than 20 to 30 years, but still we are far away from mass productions and only research is being done. The challenges are regarding the lithium battery. The stability has not been guaranteed, and lithium metals, how we can use that. It hasn't been presented with a definite clearance. So as you can see here, each company, they are taking different approach to identify the issues related with lithium batteries and to find the solutions. However, they couldn't find any solutions. But fortunately, recently, Toyota has come up with a solid battery that can be used for EV, and Toyota is about to launch, but we don't know when exactly it will be launched. What are the issues? So let's take a dive into that. Dendrite is the biggest issue, and when we talk about dendrite, unlike the existing lithium battery, dendrite is very different. When it's charged out, then in case of the issues, interconnection is not issues, but there is a needle-like dendrite growth, and it swell, and then once again the volume increases and suppress the growing of the dendrites and anode, and once again it's been divided. So this is the biggest issues that we have. So for many reasons, we have come up with a great methodology to use this, but still on top of the dendrite, we try to do the coating so that it can react with a liquid electrolyte, and such system is not enough because the lithium will be penetrated and dendrite penetrate the coating layer. Then another company came up with a new technology like coating, multi-layer coating. And when multi-layer coating is done, it can reduce the reactivity with the lithium metal, so dendrite still penetrate. Nowadays, ceramic is now being used to suppress the growing of the dendrite, or it can protect the conductivity. And probably ceramic coating is likely to present the greatest possibility because ceramic can suppress the growing of the dendrite. So we partially achieve success, but once again, ceramic, because of the volume expansion, there could be some crack, and due to the brittle, it's not flexible. And now on top of the ceramic, there's a polymer coating to suppress the growing of the dendrite. And various efforts are made. So we have done everything, starting from non-coating, swelling polymer, multi-layer coating, ceramic, all the way to polymer. And we try to find the right answer. So after much thought, our final decision was once again solid polyelectrolyte polymer structure design. As much as possible, lithium ion, when it's been covered, then it will be possible to make polymer films that can sustain dendrite. So it's not like this kind of shape, but rather, as much as possible, it will be very flat dendrite formation. So we presented that idea, and then we came up with a gel type of the high polymer. But as the lithium grows, as I have shown before, As you can see here, high polymer cannot be suppressed. We need to come up with a way to suppress the growing of the dendrite. And we came up with the idea to design the solid polyelectrolyte structure. So we begin the synthesis of that. And sorry, my slides is going backward. So the 3 layers were the system that we have applied. It's a simple, but still the best approach. So on top of that, there is a protected coating, and also it has a special property for flexibility, and it's very stable. And in the designing of the solid polyelectrolyte polymer, when dendrite keeps accumulated, once again, the separator that divides this will also increase. And although they keep suppressing the growth of the dendrite, the anode and cathode, we can stop these two being separated. However, there are also issues. The dendrite, the shape, the idea that we got is just like a cactus. And just covering the film is not breaking out. So if we create a film, then we can sustain the dendrite. So this was the idea that we started, and in order to come up with this, the cross-linking system is what we need. So we have introduced the chemical cross-linking, and then we came up with 10 times minus 3, and this has a great iconic conductivity. It's strong enough to resist against a sharp needle. And it's a semi-rigid and network structure. It's great. It can come up with an IPN structure. And that was the idea that we came up with. So, once again, definitely electrochemical or thermal stability or non-reactivity was what we really cared about. So what you are looking at right now is the synthesis films. We couldn't test it on top of the cactus, but we were able to do the testing, and we came up to conclusions that dendrite can be suppressed. So simplistically, these are the tests that we've done. Solid polyelectrolyte application coin cell test was done. Of course, our research is in early stage, but we are enjoying quite a bit of success, and our research is an ongoing. Here, we don't use liquid electrolyte, and we use low molecule, and additives and high polymer are used so that we can create electrolyte. So lithium metal reactivity, that we don't see anything. So we've done testing. What you are looking at right now is the lamination analysis of lithium after charging and discharging. So on the top is a copper plate, and anode or lithium material were plated, and right here there were no high polymer electrolytes, so we tried to find out how well the lithium is grown and how the dendrite is being formed. And about 10 to 17 micro platinum was what we expected. And you can see that the plating is about 10 micron of lithium, then it deposited on the substrate, and due to the mostly lithium, it grew up to 17 or higher, showing porous structure of the plated lithium layer. And all the way up to 110, it can be accumulated. So dendrite could be formed all the way up to 110 micron. And now what is this? Well, on the same condition, we have done coating on the low ion conductivity. And when I say low ion conductivity, it's 10 minus 3. And on top of the copper foil, we tried to do the plating on top of the polymer coating layer, and most of the lithium metal on top of the high polymer, it was accumulated. It has to feature like that. And instead, when the conductivity is low, definitely structure-wise, of course, the dendrite grew through the polymer coating layer, polymer swollen by liquid electrolyte. And polymer has a very little or high crystalline structure. And we have done the copper foil coating, and lithium ion goes down here, and it penetrated through polymer, and then once again, what I have shown you, the polymer can be used to suppress the formation of dendrite. So as dendrite keep formed, once again, the cathode and anode will be separated. So this is the system that we have applied. So we have applied this, and we try to check it out. As you can see, we try the effect, checking the effect of the preventing direct contact with electrolyte when applied as a protective films. And lithium plated under polymer layer, not on top of the polymer coating layer, and polymer layer protect lithium metal from direct contact with the lithium electrolyte. It goes below that, and dendrite are well covered. And we've done, once again, it's a before and after plating. You can see the 15 micron plating, the dendrite, as it grow, high polymer are not torn, but rather it's well covered. And if we plate with a 20 micron, you can see right here that high polymer or the dendrite are growing so much. And then even it is penetrating to the high polymer, but still high polymer are well covering the dendrites. So we are very encouraged. Even though it's a 20 micron, still high polymer are well covering dendrite. It's well preserving dendrites. What should I say? So we can tell that the testing results were really great. And especially the high polymer with the 20 micron plated, we tried to once again analyze the lithium. And you can see here that the surface of the lithium after charging and discharging, you can see the surface of the polymer electrolyte after growth of the dendrite is shaped like this. Of course, 20 micron lithium plated on gel polymer coated, and it is concentrated to one side, and it grows not consistently, but with a different shape. And when we get rid of the dendrite, we try to take the view of the plated side. The membrane are well protected. And of course, it can be penetrated, but still, my view is that if we keep testing, we will definitely find the solution. So the research is going on, and using new ceramic or other composite, we will be able to come up with a better test result. Now let me share with you our future research direction. We need to carry out a study to understand the reactivity between lithium metal electrode and polymer electrolyte. Especially, we expect to improve the lifespan of high-capacity lithium metal batteries. And currently, the reactivity is like 10⁻⁴, but that's not enough. And we need to come up with a higher reactivity, and we need to synthesize with a higher reactivity. And also, there is an issue with the solid electrolyte, Especially, we need to carry out study on the improvement of the interface between the electrode, cathode or anode, and the solid electrolyte so that we can accommodate the current flow across solid interface. So the cathode, anode, and electrode, how can we make it as one consistent? Last but not least, we need to develop a new high-loading positive electrode required for high capacity and solid-state batteries, and we need to resolve the resistance problem inside the electrode due to high loading. And high load, as you know, the cathode, when the cathode becomes thicker and thicker, ion cannot pass by, so solid high polymer we need to develop at the same time so that once again it can become more efficient. So these are our future research direction. If you have any questions, I'm ready to answer them. Any questions from the floor? Well, compared to other solid electrolyte, your idea is that it's based on gel type. So comparatively speaking, the interface contact, you are in a better position because it's gel based. Yes, you're right. If we use solid high polymer, we can totally separate it, but because this is a low polymer, low molecule, that is why the issue of the interface can be much lower. But when we do that, the separator, this solid electrolyte, cathode, anode, we need to replace them, or how should I say? We need to take action. But if we make it solid, then everything is same. Whether we do it or not, the result is same. So there are some challenges. And your target is 10 minus 4, right? That's the ion reactivity. That's your target, right? Yes. 10 minus 4. But comparatively speaking, you might need to aim at a higher reactivity, right? Are you doing that? Is it because of the surface is limited, that's why you don't expect to see that? Well, as far as what I know, when the reactivity is really good, then later on, we can come up with a better result. But the reactivity must be really good so that the surface or interface can be loosened up. And well, I don't know. I really don't know what to say. But charging and recharging, the reactivity is extremely critical. It is totally dependent on that. So we try to aim high. The benefit of gel type is that it's not liquid, but it performs all the way up to the level of the liquid. It has a huge potential. Electrolyte, gel type is great. And reactivity is to the level of the liquid type. Thank you.
네.
I have a question. Lithium metal battery. That's where you are testing, right? Yes. Polymer. Of course, you are using the features of solid, but I wonder whether it's suitable with the metal, because in the interconnection system, have you done the testing for that? But as I mentioned before, in order to match everything, cathode, lithium, everything must be tested. And until now, we haven't reached that level. And as much as possible, the resource we have, we are using this, especially cathode we are using, which means the efficiency can drop. Cycle could not be matched up. But if we are confident enough to do this, I don't know what's wrong with this. Anyway, whether it's a high loading or not, we need to solve the resistance problem. I have another question. I'm Kang Tae-woon from EN Plus. Well, 10 minus 4, it's your target. That's extremely important. But I think you have to resolve the issue of the dendrite formation. Your technology is really well developed, and everyone are working hard to enhance the reactivity. But if you look at the second battery, nowadays it's replaceable. So from that point of view, charging and recharging, you don't have to speed it up. That's my first idea. So I dare to say that if you want to focus on, you need to work on how to get rid of the dendrite formation so that you can put the energy density on par. And if you do that, definitely the battery efficiency and performance could be much higher. You are right. You're definitely right. Everything you said is correct. Yes, it's our greed. And we are ambitious enough. We want high density with a great performance. We want the best. But if everything goes well, that's great. If not, then that's not good. So that is why we are aiming at 10 minus 4. May I ask one question? You briefly mentioned that depending on the thickness, you've done a lot of testing. Can you show us the slide? Depending on the thickness, if the platinum is 10 micron or 20 micron, is it the time span, is it same or different? Well, these are 3 different cells, and that's a before deposit. It's definitely before plating, and this is, we have calculated, we decided to come up with a 5 micron, and this is 10, and this is 15, and this is 20 micron. And after we've done plating, we cut horizontally and we try to check it out. So what about pressuring? Yes, we did it because we produce coin cell. That's why we have done pressuring, and it becomes bigger. So remember I mentioned to you about all of these, they have formed the coin cell. So it's and all 3 of this. Right after that, once again, we need to cut it. So you cut it right after. Yes, we did it. Inside the dry room, we cut it right away with using optical microscope. We cut it by half. Thank you. Thank you very much for the great presentation. You have touched upon the area that we are all interested in. Thank you very much.
다음 발표는
Next, from Emerson Automation Solution, Mr. Lee Sung-woon will be making the presentation.
네, 안녕하십니까.
Hello, everyone. I'm from Emerson, Korea. I'm in charge of the battery business. My name is Sung-hoon Lee. I'm very pleased to meet you all. In relations with the battery, I've been visiting many places, and usually researchers come up. And regarding the mass production, no one is interested in mass production. That's why I'm here today. Let me briefly introduce my company. My company is automation. We are a leading company in automation. Headquarters located in the United States, in St. Louis. About 20 trillion is the revenue. And I can proudly say that we are listed in NASDAQ for the past 60 years. Never once we have reduced the dividends. We are working hard to enhance the shareholders' value. So we are a great company. That's Emerson at a glance. We talk a lot about ESG, so sustainability and decarbonizations we are deeply interested in. As a part of that, we came up with a solution called greening. Greening of, or greening by, or greening with. These 3 are our slogans. So in case of greening up, we are trying hard to do something, decarbonization and sustainability within Emerson. So we are driving our greenhouse gas emission intensity by 20% by 2028, reduced by 5.8% in 2019. In case of greening by, we are trying to provide product, solution, service to help our customer transition to low carbon by. And the title of my presentation is related with the greening with. As you can see, when the government come up with the policies or future directions, we try to engage with external stakeholders by partnering to develop innovative solutions and participate in sectors and customer initiative. Now my company is working hard to achieve green by so that we can do sustainability and decarbonization categories. So hydrogen, battery, emission control, energy efficiency, other clean fuel, these are our business portfolio. And battery business is one of them. And hydrogen is also another area that we are working hard. Now, in 1988, Emerson Korea was established, and about 636 employees are working. And the headquarters of Emerson Korea is located in Chukjeon, Gyeonggi Province, and also Ulsan, Busan, in various different cities. We have offices to provide support to our customer. On the right side, you can see the photo of our solution center that are located within our factory. And demonstration plant is located within our plant. So when customers visit, we can take our customers and then show our solutions. So we have created that site, and most of the large conglomerates every month visit our demo center to see this. And now let me dive deeper into the main subject, which is the lithium-ion battery. Well, in order to explain to you the lithium barrier, I have to explain the whole value chain. We call this as a value chain in Korean. We classify into upstream, downstream, and midstream. In case of upstream, that start from the mining of the minerals, and then we need to refine that. And also the materials that are refined from the mine, we divide into cathode, anode, electrolyte, or separators. So different companies bring these, and then processing will be done. In case of the anode, it could be regarded as a precursor. So cathode, anode, separators are all built in. These materials are used, and three major companies are producing battery cell using the cathode, anode, and separator that we produce. The battery cell, as you know, we have different types, a pouchy type or regular type or different types. And then we also operate battery management system so that automobile company can use that as well. Now, if you look at our business portfolio, we provide solution, automation solution. As you can see here, for the mass production, the most fundamental thing is the controller. And controller, temperature, pressure, everything are being controlled and managed. In order to produce battery, the most important process is batch process. And batch process means that within the tank, various kinds of materials are mixed together, and then we can come up with an exact, precise performance. So the amount of the mixture or the density is the most important element. After measuring that, and all of this information will be sent to the controlling system. So when this controlling system receive that, then they give order to valve, and then they can be controlled. And when these informations are gathered, cathode, anode, or different companies will give us data, and then we'll be able to manage that. You know, the IoT technology has really developed based on the data, and then the customers can ask for an exact amount of cathode, anode, and to meet their expectation, we can operate in a much more efficient way. Those are the solutions that we provide. Now, this is the business challenge that Emerson Korea envision. Of course, we provide cathode, anode, separator. We do a lot of business with them. And in a way, we understand the customer's need. We understand what are the challenges faced by the customers. Of course, we don't have any mining company in Korea, but in case of POSCO, they're about to launch refining business. And in case of POSCO, in Argentina, they are taking lithium from Argentina and will do refinery work. And also, POSCO will be doing excavating work and mining in Australia and bring lithium and then do the refining work. So, in case of the mining, there must be a production optimizations. How can we produce it in an optimum way? We need to understand the correlations in operation with the predictive control features of delta V, maximize availability process. And these are not environmental friendly. It has toxic material. It's also corrosive. And how can we control emissions? How can we reduce the energy utilization? So those are the major concerns of our customers. The corrosions, erosions. These are the challenges, and how can we optimize the productions? And there are various processes, but we are monitoring that. We have many systems that we are preparing. And in order to be equipped with reliability, refining and mining process, if you watch that, there are heat exchange or compressor, and we need to efficiently use that. Only then we can improve reliability. So implementations of the wireless heart technology, vibration monitoring, condition monitoring software, data analysis, we can provide all of that. So Emerson Korea provides these to our customer. Now, regarding emissions, from the mining side, we call this as a cleaning, and we are actually having the process of utilizing the predictive control model for clean combustion operations, and there could be some wastewater, and we need to process the wastewater, and we are trying to decrease O2 buffer by using consumed air algorithm. In Korea, of course, there are many companies working hard, but mostly Samsung, LG, SK are the top leading company in producing batteries, and all of our attentions are focused in these three companies, but there are many Korean companies that produce battery components. We are doing business with them, and also we are trying to resolve their hardship or difficulties. As I said before, our major concern is how to optimize the production so that we can produce the right amount. If it's NCM, then we need to produce NCM, then nickel should be 8, magnesium should be 2, and the copper should be 1. So this should be measured. Of course, at the research center, we can do that, but in the actual process, the tank is much bigger than the human being. So in order to measure exactly the right amount, the process and solution should be right. And we are working hard with the customer so that we can do our job right. As I mentioned before, in case of the cathode, they use a lot of toxic materials, and also precursor Li2S is also being used. So they have to use this. And if they use sulfur, then inside the pipe there could be some erosions or corrosions. And we need to monitor that. So pipe monitoring system needs to be devised, or monitoring the batch is also another solution that we provide. At the same time, as I mentioned before, since we use a lot of sulfur, so the safety of the workers are critical. You know that nowadays we have this special law, and if the serious accident law are violated, then we will face with a great penalty. So we need to get rid of all these toxic materials as well. I believe Samsung, LG, SK, these three companies are the biggest cell maker. They have the similar concerns. The cell manufacturing process is usually a simple one, like rolling or slitting or packing or conformation. So in a different unit by unit basis, each process is being done. In each processing, as you know, different companies are working, and they also are involved in commercialization. If their automatic solutions are different, we need to integrate them so that LG, Samsung, SK can control that in an integrated control room. How can we do that? These are their concerns. This is so-called system integration that we provide, and through various solutions, we are trying to resolve these issues. And also, when they produce cell product optimization is a metal welding. That's part of that. So advanced ultrasonic technology, which are suitable for thinner foil and tap welding, is what we need. There could be various ways, but high technology is needed. Less heat, and also we need to target precisely so that the customers can manufacture in an efficient manner, and also we help them. Now, regarding the safety, because there could be toxic materials that are produced by product, and the heat that comes out, there could be a lot of issues. So in that sense, we work hard to provide the solution. So in the process of depositions also, we are working to provide solution. So simplistically put it, the battery research is important, but when we mass produce them, can we precisely produce the product that happened during the research institute inside the lab? Can we do that? And Emerson provides various solutions. Any questions from the floor? Well, you mentioned Emerson Korea as a solution provider. And after everything's are done, the data will be handed over, right? Because you mentioned, say, you provide all kinds of components, but you have the data, right? To data accumulations or data monitoring, how much do you have that? I mean, so you must have a parameter, right? Like welding or such and such work. You have all the data, right? Yes, of course, basically, as long as the customer would like to measure that, we do that. When the customer asks us to do the evaluation or checking or monitoring, we can definitely gather that. So together with the provider, you provide everything. Yes, we provide as a whole full solution, starting from the measurement all the way. We provide that. So the measurement, you can even develop that. You can provide that. Yes, definitely, we can do that. And inside Korea, we have factories, but in Europe, in American regions, we also have the factories. Korean companies, they have different factories in different places, and all these different factories can be monitored by one control room. So from A to Z, from starting point to the final stage, Emerson Korea can help the client to gather the data, to monitor everything. But there could be various points that you need to work on. Now, my question is, in case of the semiconductor manufacturing, you know that they accumulated all the data. So when something happens or some mishap happens, they can immediately identify, like, for example, there could be some slitting in the slitting process, or the cutting was not done properly. It can be measured. And you can do that too. Yes, we do that. Yes, definitely. We provide those kind of things. Okay, so you provide a solution. Okay. Well, you know that these are the fundamental things in mass production time, so we do that as well. So Emerson Company, do you do semiconductor business as well? not much, but in the fat area, we don't do much. But mostly in the lithium or other sectors, we do the business. Thank you.
굉장히 좋은
Great presentation. Technology development is important, but also product quality is very important. Any questions? If not, then we go to the next presentation.
플러스
Now we would like to invite Vice President Kang Tae-kyung from EN Plus. He will talk about the heat-proof technology and conductive additive for global EV technologies.
안녕하십니까.
Good afternoon, ladies and gentlemen. I'm Vice President Kang Tae-kyung from EN Plus. In participating in this forum, I feel like I'm at the right place because I'm learning a lot today from my fellow speakers, LPN and Green Energy and Emerson Solutions. I'm sure we will have a lot of business opportunities for collaboration. Let me be very brief because we are running behind time. I'll talk about the global technology trends for conductive additives and heat-proof for EVs. It was kind of confusing. Can you go back to the previous slide? I don't know which direction I should be moving with my clicker. Am I the only one who's confused? I don't think I need to go backward. So EM Plus is a environment-friendly new material company. EM Plus is listed on KOSPI, and we are developing environment-friendly material. Our revenue as of last year was 55.8 billion won, and this year it's 67 billion won. And for new material division, for which I'm responsible, we have 21 R&D personnel, and we'll be recruiting a lot more. If you have anyone who are looking for jobs, I would love to interview them. And we've done a lot of industry academia joint research, and we have worked with KAIST, Hanyang University, Jeonnam University. We have outsourced a lot of R&D projects to academia. This is our four major business areas: CNT, graphene, battery, heat-proof, and graphene supercapacity. And we are doing conductive additives. So I don't think we have any direct competitor here. Our research center is located in Annam, and we have a plant which will be finished in September this year. So these are four business areas for our company. And let me briefly go over our company's history. And we have achieved 41 billion won of sales. And beginning 2020, we began developing full cell for 260 watt. This was not designed for sales, but I will talk about this later on. In 2021, we have signed next generation battery joint development agreement. Since we are an SME, we have participated in a lot of government-sponsored projects to build our credit and trust in the market. Of course, our sales is not big, and our R&D budget is not big when it's compared to large corporations. But given our sales, I think we are making a lot of R&D investment. In 2020, a lot has happened, and we participated in a government-sponsored project organized by Ministry of Maritime and Maritime Affairs. And we won the project. And then let me talk about carbon material and property by carbon material. Since you are experts yourselves, there are artificial graphite, carbon black, active carbon, and carbon fiber. And let me skip this. And nanomaterial. In order to replace carbon black, we have developed, there is the CNT. Graphene is not being commercialized yet. CNT, it is used for secondary batteries. For secondary batteries, the cathode and anode material play a very important role, as well as the separation layer. Carbon nanotube is competing against the 6th and 7th to become one of the top 10 material. And we are looking for CNT, carbon nanotube, conductive additives. And we are looking for ways to compete here. CNT, conductive additives. We are trying to develop CNT, conductive additives that has the highest efficiency. Single wall CNT, fuel cell CNT, multi-wall CNT. As for multi-wall CNT, it is most widely used. For single-wall CNT, it seems like an excellent conductivity, but it's very expensive. So we are looking for something hybrid between single-wall and multi-wall. And CNT itself is used as a catalyst for synthesization. We have been studying this for 15 years, and there's the combustion method and co-precipitation method. And CNT type. As for secondary batteries, and many people ask what CNT is the best, but there is the entangled CNT and bundle CNT. Entangled CNT is like wearing a permanent on your hair, and without straightening it, the conductivity property will go down. In order to straighten the curly hair, then the decentralization or dissipation would be slightly more difficult. And bundle CNT has excellent conductivity, and it has excellent decentralization property. And for CNT, let us talk about what kind of CNT is the best material. Material providers, they sometimes exaggerate the property of their material, but we use Laman methodology to identify the best CNT material. The wavelength, there are 3 types of wavelength, 532. When the ratio is 0.96, we say the CNT is the best. On the right-hand side, it shows the IDIG ratio. IDIG ratio has a lot of dissertation articles written about it. And when we studied this, ID prime IG ratio, if we can fine-tune that, we can come up with excellent CNT performance. And with excellent conductivity, we'll be able to see much better data. And this is rather complicated, so I won't go into the details. Multi-wall CNT and single-wall CNT. Multi-wall CNT has a lot of tubes. Single-wall CNT has 1 to 2 layers, and there is a lot of difference between D-band and G-band, multi-wall CNT and single-wall CNT. Single-wall CNT IDIG is 0.11, and multi-wall CNT, most of them are commercialized. And when you develop full cell with that, and the medium number is 1.023, and until that range, the performance is fairly good. But if you're looking even better performance, then the ID ratio should be 0.053, and with that, the purity would be the highest, and the performance would be the best. And I will skip this because you all know this. And cathode and anode. For cathode, we have to use it to lower the resistance and reduce the usage rate. And whether the conductivity material is metal or silicon, well, they all say they're the best. But off the record, I think compared to lithium metal, silicon, I think they're going to be used for 70%. We don't stick to single silicon material, but when we test with silicon, silicon expands a lot. And I'll get back to this later on. CNT, multi-wall, single-wall CNT. Single-wall and multi-wall has R&D prototype phase. Multi-wall has higher productivity or production rate. And the raw material, intermediate material, finished material, and the right-hand side shows S Hyundai. And I think it's going to be great because energy use creates a lot of heat, and we need heat-proof technology and cool down. And let me skip. CNT from 2021 to 2028, we've seen about 10% annual growth rate. And the numbers might not be correct.
It's around, it cannot be 10.5 billion, but it could be anyway. So CNT is growing rapidly. And in terms of the growth rate, in the second battery, all the way to electrolyte, separator is continuously being used. So the growth is slow, but still the volume is huge. But in case of CNT, about 2 to 3 years ago, the growth has been exponentially growing. And in case of silicon, of course, it's minimum nowadays, but in terms of the unit price, it's much more expensive than graphite-based one. So it's about 70%. Once again, the expanding capacity between the companies to realize the economies of scale, it can go all the way up to 20 to 26%. And now let's go into this area. So the raw materials are lacking so much, so we expect that it will be increased like by double. This was analyzed by another security company. I'll skip this. Now let's look at the SWOT. My company, the greatest strength is that we have experience operating the graphene battery, and the researchers have also not developed the second battery, but the materials that go into the second battery. And the weakness is that the name value of my company is low, and I was told that I should visit and come the meeting like this so that people know more about my company. Well, I guess today's opportunity is great so that people know more about my company. And the threat of course, there are a lot of threats, but we can definitely overcome that. Now, going into the business model, nowadays, LFP is the major trend, and lithium, we have this. We have signed the MOU, and Kangfeng Lithium is a Chinese company, and we provide our product to Kangfeng Lithium, and Kangfeng Lithium operate like 14 gigabytes. As long as we provide to Kangfeng, I guess I don't have to work hard. But anyway, we need to work hard. We need to expand our customer base. So in terms of the material, we provide to the automakers or to the final end user. I used to work at Samsung SDI. When someone provided, I usually feel burdensome to do that, especially the second battery is very dangerous. We don't easily replace that. So what we came up with the idea is that if we do that, CNT solution should be manufactured nationwide. And just like we do that, we need to visit every single company and distribute our product. And we can tell them that we can produce a full cell, and please evaluate how you feel about this full cell. And we'd like to enter into the market much faster than any other company. Since we are involved in this area, conductive additive, and Europe is NFP based, and they are not environmental friendly. There are a lot of regulations, and they are trying to come up with a better one, and probably next year, the first quarter of next year, we'll be able to provide to the European market. Now, if you look at here, CNT, instead of saying yes or no, or it's good or bad, carbon black is about 0.022, and this is a volume resistive, and about the MNCNT is about 0.017. And if you evaluate the full cell, please use the conductive additive produced by my company. On the right side, you can see the cathode and also the conductive additive, how it is resisting. And in our case, you can see that it's not horizontal, but it's vertical. Vertical one is more important. And the carbon black, compared to that, about 10 times or 7 times, it's much better if you look at the resistance. Now, CNT types, I'll skip that. And NMP water, NMP base, about 0.7 and about 0.5. So 5.0% for the cathode, and it's once again the conductive additive that is being used. And the second battery maker, about more than 30% of the cost reduction is possible. So we see a bright future for my company. And we also develop pouch cell, and compared to carbon black, and 0.5C, nobody is interested in that. So when we look at 5C instead of 0.5C, if it's charged, then 60%, it discharged 0.4%. So about 96% in the middle, you can see that these are the mass-producing models, 0.3 or 0.2 C. So C rate is really high, but the efficiency is really, really good. And when I look at that, once again, if I evaluate this, CEO Chung mentioned, and I expect to see like 99%. So I look at your recipe, and I really hope that Dr. Chung and we can work together. So please keep in touch. And now here is a pre-processing solution. Lithium battery, you mentioned. Yes, the dendrite formation is one of the issues, but copper and also lithiums, when you look at the life cycle, you can see lithium metals, the life cycle decreases. So that is why we need to do some coating or pre-processing is necessary. And nowadays the coating or pre-processing are very popular, so we send them as a sample. This is about the carbon coating, and we have done this before, and the conclusion that we came up is really great. Basically, pre-processing or the coating is what we call, compared to the other company. I think the S company is developed in 2011, but the life cycle, if you look at that, reactions to the water or electrolyte, the result was quite negative. So we have come up with a design that is very unique to us, and graphene solution is what we have done. And we got approval from one of the Korean company, and we provide that. And graphite solution is not just one simple product, but we do blinding solution, and silicone graphene solution is what we provide based on the request from the customer. And it was approved, and we wonder why it has happened. And we came to a conclusion that it's related with the total volume. But also, the graphene is coated, then there's a ceiling or the temperature like 3 degrees. When it's improved, then life cycle can be increased also. And that's how we got a great result. That's our prediction. And also, in case of the heat proof, energy density goes up, and definitely we need a heat proof. Here, what you need to pay attention to is that in case of heat proof, we've done working with the IT, but mostly nowadays China is doing that. The heat proof panel is produced, and we cannot work with any Korean company. And then we found out an opportunity. So this is where we see a great future. This data was made in 2018, and if we look at 2023, 2.4 million is the market size that we expect. But by 2025, the market will be huge. In our case, the heat proof, we have thermal pad about all the way 10 gigawatts, and also it should be thermal conductivity and volume resistivity, thermal conductivity, density. These are the major features. But also it's quite difficult to get access, so we would like to continuously do the R&D activity. And now gap filler is what we are working on instead of a thermal pad. In case of thermal pad, we had a cell module pack, but now it's a cell to pack. So in the past we've done cell module pack, but now cell to pack, and it's about 9 to 10 centimeter. And EM Plus has come up with 1,200 millimeter that can cover cell to pack. And as we move to the cell to pack, once again EM Plus will be able to enjoy a great benefit from the customer's point of view. They can reduce the cost, but there's a huge heat being emitted. But using the thermal pad, we can become the winner. And on the right column is a gap filler. And in case of the automobile battery, we call this as a shash, and gap filler will be used here. So module and pack will be covered. The car itself is huge, and Ioniq 5, I tried to disassemble that, and the roughness, yes, I was able to witness that. So if we coat that, once again, the heat will be dissipated, and instead of the thermal pad, gap filler is much better. Just a small amount will work, and also it can become a lightweighted vehicle. Now, it's been quite some time ever since I took this photo, and 80 meter or 100 meter. We are currently building a factory. The coating equipment has already been completed, and just to make you laugh, you know that we have been able to purchase the apartment, but the apartment complex has not been built yet, so we cannot enter the new house. So that's just what the status is for our factory. And if you contact me, we can discuss about future business opportunity. Thank you.
Thank you very much. If you have any questions, I think we can spare 5 minutes. Thank you very much for the wonderful presentation. Thank you for your attention. I would like to thank all the speakers for speaking today. And we have about 30 minutes. And then we will take a 5-minute break. And then we will have a 30-minute free panel discussion session for about half an hour. Thank you. We'll see you in 5 minutes.
시간 남았으면 더 얘기할 아유, 제가 성함만 맨날 들어가지고.
예.
강태영.
네, 김동동입니다. 고맙습니다. 저기 명함 하나 드릴게요.
네, 알겠습니다. 보상 안양에 좋은 정보도 저희는 연구소가 양감면에 있습니다.
협력할 부분이 많은 것 같습니다.
예예예.
아, 예. 잠깐만요.
협력할 부분이 많은 것 같아요.
네, 김동동 교수님, 감사합니다. 예.
네, 안녕하십니까. 그러면은
Ladies and gentlemen, since we are behind the schedule, we'll have a short panel discussion about the future of battery and the battery market. I have prepared 3 questions, and I will ask these 3 questions to the presenters and get their feedback. Dr. Jo Myung-dong from Greenergy has talked about solid polymer electrolyte for high energy density and
생산
and also the production facility. We have participants. And in case of the next generation battery in the EV market, what kind of innovation can we expect? That is my question to Dr. Jo. Dr. Chung also mentioned globally, I believe that Toyota has the greatest number of the patent. They are very active in terms of doing research in this area. By 2030, according to the press release, 6 trillion to 7 trillion is the amount that is likely to be achieved in the market size. Not only in the high energy density lithium battery market electrolyte for, but also the overall second battery, the market size about 6 to 7 trillion. Then the second battery market, will that be replaced by electrolyte for the high energy density lithium battery? It will give an impact to the EV only, or overall? Will the electrolyte for high energy density will provide a new innovations to the overall market? That is my first question. So regarding my question, I hope that anybody can answer. If not, then I'd like to ask CEO Chung.
예, 저 배터리
I'm not a battery expert because we are a material provider. But whenever we talk about solid state batteries and precursors, of course, we have the speaker from SDI. And then people talk about cathode when we are actually talk about anode. And precursors, I know, can precursors really change the EV market? And when we talk about the precursors innovation for performance, of course, I agree that there is a need for such innovation. But in a large system, can we really offer the low affordable price that OEMs are looking for? Because the liquid-based technology, can we really achieve the safety with the precursors? And I think for precursors, it's better for injecting into human body. Thank you. Thank you. And from EM Plus, Mr. Kang. And when it comes to other technologies, is there any other candidate technologies? And all solid state batteries for lithium metals? Well, I believe that all solid state batteries, when they were popular in the past, I have talked reviewed and created 419 kilogram. It's about the size of a smartphone. And I have created about 10 of those. And it cost 2 million won per unit. And even though energy density is low, the sales price for S is $3.5. So can they really afford to buy 2 million won batteries? Because EVs are now already very important, very expensive. And all solid-state batteries, LG, SK, Samsung, they have invested a lot for batteries. And they have to achieve break-even points. And anode coating, this requires huge amount of investment. For secondary batteries, well, for high temperature, it's relatively better, but for low temperature, there are some bottleneck. When, in the case of driving, 30 to 40% of efficiency would be lost. And in order to overcome that, we need to change a little bit of additives. But it's difficult to overcome this problem through materials, but we could create nanotube CNT. Heat creation can use this. And external temperature is minus 30 degrees. It can go up to minus 10%, and the efficiency would be as good as room temperature. The material is evolving, and heat creation materials or other energy density. So today in Jeju Island, the weather is 20 to 27, but if we run, the efficiency would be lost because it can go up to 40 degrees. And fuel efficiency, to improve fuel efficiency, we could use carbon fiber or cell-to-pack energy density. And recently, our car trunk would have golf clubs, and that could weigh quite a lot. If we can reduce the vehicle weight by 10%, 10 kilograms, the efficiency would improve by 3 to 4 degrees. And for heat process, heat proof, we also use a lot of this. For low density, it will greatly improve fuel efficiency. For secondary batteries and surrounding technologies can help that. Samsung Electronics and Apple, they're competing for smartphones. Compared to Samsung Electronics, Apple is making more money with its accessories. But in our case, since battery market is very small and material component suppliers, if we can develop good technologies, I think we'll be able to achieve win-win results.
지보다는 좋은 소재.
Well, I guess instead of coming up with a solid state, it's better to have a more systematic engineering. I guess that should be our answer. That was my first question. But in case of the solid state battery, definitely this is a big topic. And I'd like to pose a question to Emerson, Marketing Manager Lee. Well, globally, a lot of investment are pouring into the solid or quantum. These are the companies that are focused on the solid state, and they've done IPO, and the market capitalization goes all the way to 3 to 4 trillion, but the revenue doesn't exist. But as I mentioned before, technology development is great, but quality management and also realizing that the market revenue is important. So what kind of technology do you have to carry out quality management? So what is your plan to do that? Well, in terms of the technology, I'm not in the right position to give you answer about that. And instead of mentioning about technology side, I just want to share with you the expectation and concern about solid state battery. Now, regarding expectation, the cars are transitioning into self-autonomous vehicle, but the capacity, the volume of the battery is important, but will the LIV be fully capable to do that? That is a big question mark. My concern is in terms of the technology. In 1988, LIV was first came into being by Sony, and LIV is a big boom. It's been 3 to 4 years, and it took about 3 decades. Then the solid state battery, of course, we are in the initial stage of development and time has gone by, but within 20 to 30 years, will we be able to mass produce solid state battery? Is technology-wise, is it feasible? That is my big question. Now, from the position of Emerson, in relation with the solid-state battery, we have not done a lot of pilot project, but a couple of that we did together with a P company in Japan. We've done it together, but the influence of the P company, we weren't able to enter into the mass production stage, which means that the technology-wise, it's not feasible yet to start mass production. That is my answer.
역시 양산이 가장 중요한 거.
So mass production would be most important. Then we'll move to the last question, and I'm sure it's going to be most difficult. I have question to Dr. Cho. You have said that Greenergy is developing gel-type, polymer-type electrolyte for your batteries. And we need some clarification. There is the all solid-state batteries, and then Green Energy is developing hybrid solid-state or semi-solid-state batteries. Can you explain the difference between these? And as the speaker from Emerson has mentioned, mass production. What is the biggest challenge for mass producing all solid batteries?
맞는 말씀이 맞죠?
저도 짜증나요. 안 돼서.
잘못된 거로 그냥 끝나버려가지고.
그러니까
우리가 그 메탈 시스템, 소리 메탈 시스템이 사실 기술적으로 너무 비싸다고. 비싼데 사람들이
제가 전고체를 하기 때부터 초기에 시작했어요. 그게 86년이거든요. 아직까지 못 되고 있잖아. 그러니까는 40년 된 게 아직.
저는 자신 있는 게 뭐냐면 기존의 그 레거시라고 얘기하는 시스템이 너무 많이 깔렸기 때문에
네.
전고체가 이걸 죽일 수 없어요.
맞습니다. 그건. 네.
그러니까 아주 한정적인 부분에서 나올 거예요.
네네. 아 이미 그 상영이 이메일 보내드렸습니다.
절대 메조리티 가져갈 수 없다.
네네.
수고하셨습니다.
예.
목사님.
맞아요. 좋은 자리네요. 좋은 자리. 자주 올게요.
메뉴로 오시죠.
예.
아이고.
고생하셨습니다.
아이 감사합니다.
아, 유트메탈 폭발 안 하셨어요?
많이 했죠.
아 예.
안녕하십니까?
Ladies and gentlemen, now we are going to start the second session for the 6th Global EV Round Session, second day, second session. I'm Professor Choi Ung-chul from Kookmin University. In this session, we are going to talk about EV charging business. In the previous session, we talked about battery technologies. And in order to facilitate the use of EVs, charging infrastructure would be playing a critical role. So charging business requires a lot of strategies. And we have invited experts in the field. First speaker is Dr. Shin Kyu-sik, the head of R&D of Easy Charger. And then we are going to invite Chairman Kim Hyun-jun from Chargin. Third is CEO Choi Yong-gil from Pumpkin. And after the presentation, we are going to have a brief break, and then we will have a panel discussion or Q&A session. First, we would like to invite Dr. Shin Kyu-sik from Easy Charger. Please welcome Dr. Shin with a big hand. Good afternoon. I'm Shin Kyu-sik from Easy Charger. Nice to meet you. I have been participating in IEVE Expo in the 9th year now, and I believe we'll see even more changes next year as we celebrate the 10th anniversary of IEVE. I'll talk about platform builders and platform providers in the charging business. This is an introduction of our company. Charging business, as a charging business, if we can look at the history of our company, we can kind of predict how the charging business would change in the future. Our company is located in Kuncheon district, and we have branches in 10 regions around the country, and our business areas include EV charging service and charging system development, manufacturing, charging platform development, and maintenance of charging infrastructure. In 2018, we started our business, and we have been incorporated quite recently. But what about other companies that have been in the charging business much longer than that? We were incorporated in 2019, and since then we have continuously grown. And in 2020, we have registered ourselves as a business, and we received seed money from Humex. In 2021, we got Innovis certification, and then we have received the project for operating Tesla Korea's charging infrastructure and Korea Electricity's charging infrastructure. And this year, we are operating and managing BSS platform. BSS platform is Battery Box Swap System. And we have developed the platform for BSS. We have received various certifications, And here we have electricity safety technology provider certificate as well. These certifications kind of show the course of direction for our future growth. And let's take a look at the industry trend. In 2030, this rapid charger, 457,700 is expected, and the Ministry of Environment, Ministry of Commerce Industry, they are providing the support for charging infrastructure, and each local government has been supporting the charging infrastructure as well. And by 2030 national roadmap, the private sector is going to lead the distribution of charging infrastructure. As the battery capacity goes up, we need to develop and distribute high-capacity charging system, and we also need to standardize the system. And as for charging system is converging with other systems and other services as well. And the strategy must be carried out in a flexible manner. As we have more EVs, for example, in a tourist destination, then there should be flexibility in providing electricity to that region where the EV has increased. And I think this issue is being discussed as part of this year's IEVE. And as more and more mobility requires electricity, we need to develop more diverse charging systems. And there is the high-speed, super fast charging, remote charging. All those technologies are being developed now. And there is also low-speed, slow-speed chargers. And we need intelligent and highly efficient EV charging infrastructure. It's easy to say this, but developing the technology to enable this would be quite challenging. And for user convenience, we need sustainable charging system, maintenance and repair system. The blue area, blue letters here say the need for sustainable charging, management and repair. These are the people who are responsible for charging in Korea. And there's the central government and the public institutions. We thought that Korea Electricity Power was one of the public institutions. And since 2 years ago, charging business has made their own investment in the market to install their own charging systems. And OEMs, local governments, since a year ago has been making investment for installing the charging system. When I developed these slides, these are the things that I have referred to. I know all of you are experts in this area. But what do you think are the major way of charging in Korea? So I wanted to explain that. Super fast charger is usually for 350 and between 300 and 500 kilowatt. It is fast charger. it is not widely used. For DC charger for 20 to 30, they are not widely used in Korea. I wondered why the companies are considering medium speed charger, and they say they see some potential demand in shopping malls. So we might see medium speed charger in the future. And there's the slow speed charger, 7 to 11 kilowatt. Last year we did not see any 11 kilowatt hour charger, but we are beginning to see it this year as it qualified for subsidy this year. But between 7 and 11, the price gap is not large. So I don't think 11 kilowatt hour will be hugely possible. And we are seeing kiosk type slow speed chargers in the market as well. And one of the unique items from Republic of Korea is low-speed charging, especially for portable chargers or emergency chargers. And there is also outlet charger. You plug it on the wall and then charge your device, which is billing as used. These are unique chargers developed in Korea. And wireless charging is gaining momentum, and they are being tested now. And battery can move around to be charged. Battery swap, I'm sure it is no longer used in Korea, especially for Jeju Island. And in China, they are developing battery swap technologies for passenger cars, but we have to wait and see what happens with this technology. And for robot chargers, they are not chargers, but robot chargers are going to improve the convenience of charging. And let's talk about the location of installation. On general highways, there are super fast or fast chargers. In the shopping malls, there might be slow charger. In residential areas, there could be high-speed, low-speed chargers together. In Korea, what would be the charging technology that would account for 50% of the market share in Korea? And the cars, as we know it, well, should we rely on gas stations to charge them? But in the residential area, I believe there will be the main demand, and residential area would be the main charging point. And I have been driving Corona for 3-4 years now, and then I usually charge it at home, and I live in an apartment complex. So I don't feel that much inconvenience in charging my EV. So I think more and more cars will be charged in the residential area. There will be diversity, but I think more than 50% of the market share will go to residential area. And changes in communication protocol, we are moving away from proprietary protocol to the government-led protocol 2.0 or 1.6. Will the companies accommodate 1.6? Well, the market situation might be different from what we expect. So we have to wait and see what happens in the market. regarding the charging technology, in the past, central government used to decide this, but now we are cooperating more with the local governments so that there is a lot of collaboration going for charging system installation. Well, usually charging systems were installed in an area where it's most convenient to install the charging system, because salespeople decided where the charging system will be installed. Whenever they can sell and wherever it is convenient to install the charging system, that's where the charging system was installed. But situation is changing now. The charging system is now being installed in areas where charging is needed. And that creates a lot of problems, like the electricity problem and the shortage of parking space, and also charging time could be problematic. So all these factors need to be harmonized to create convenient charging environment. And since 10 years ago, the charging businesses or corporations, when it comes to receiving funding and investment and increasing their sales, they are going through this kind of growth phase now. And charging businesses, in the past, they all used to belong to the same single industry, but sometimes parking lot business invests in charging business, or the payment settlement providers are now coming into charging business as well. So a variety of businesses are converging around charging business now. And charging businesses are collaborating with these entities. Charging businesses are collaborating with rent-car companies as well as financial service providers and shopping mall complex and others, etc. The major goal of such collaboration would be to maximize the number of users. That is why charging businesses are collaborating with other partners. And that would definitely increase the level of convenience for EV users, and to other customers, they can acquire charging business users as their new customers. When we analyze the sales and position of charging businesses, well, they sometimes manufacture chargers themselves, or charging platform providers sometimes has charging business, and manufacturing chargers and providing platforms can also be done by the same company. And when it comes to existing infrastructure, nobody is willing to go into that technology because this charging system requires accommodating diverse technologies, and there is a strong need for personnel management. And now there are some other solution-based companies for charging system. Beginning this year, we are filling the gap. And compared to other charging businesses, we have weaker portion of charging station management, but I will get back to that later on. So we used to talk about selling jeans, but we are not selling jeans here, but I think We are building the charging system, and we are creating the after-sales support processes and businesses. And we want to be the basis for charging business owners. And these are the platforms that we can provide now. And for 3 to 11 kilowatt charger, there is a market potential. And also, we are collaborating with other stakeholders like hostel operators for installing high supercharger. And there's the control tower, and Tesla or KEPCO. We provide services to these companies, and some charging companies now feel uncomfortable hiring employees for that. But this business is a core business that will continue to grow. And we are looking into installation and management that other companies are not involved with. We believe this is going to be a blue ocean business opportunity. So to share the conclusion, when platform providers enter into our market as a platform builder, we can support this market. Thank you very much.
대단히 감사합니다.
Thank you very much. So, Dr. Shin, you have talked about various types of charging system, the installation, and the market structure. Now we will move on to Chairman Kim Hyun-jun from ChargeZin. He will talk about solution and platform providing using slow electric vehicle charger.
Hello everyone. I am Kim Hyun-jun from ChargeZin. Today, I was asked to make a presentation, and I pondered upon what should be the best title. Since we are talking about slow or fast charging, all kinds of charging systems are coexisting, and we are going into mature market. That is my thought. So, in the very beginning, we started our business as a platform provider. So from the perspective of a platform provider, how should the charging service continue? That is the title of my presentation. The title of my presentation is Solution and Platform Provider Using Slow Electric Car Charger. These are the contents of my presentation. So, first of all, EV charging business, there are three elements. First, in order to be involved in the EV charging business, we need a space where charging can be done. And second, we need electricity so that charging can be done. Third, time, so that a charging can be done. As long as we have space, electricity, and time, then EV charging is possible. Of course, the space is very much limited, so preemptive electricity is limited, and manage it and optimize time as needed. Electricity, we use it very conveniently, but electricity is limited. That's how we believe. So, the limited electricity, how can we manage that? And how can we optimize the use of that? Most of the people who ride EV, in order to charge EV, they need to spend a certain amount of the time. And how can we optimize how can we charge our EV. So building charging infrastructure, finding the optimal point between these three factors are important. The three keywords that I mentioned, space, electricity, and time, based on that, more than 200,000 EV were provided and are running in Korea, but there are constant conflict going on because of the lack of charging infrastructure. Most of housing complex in Korea are composed of apartment, and there are conflict among the EV drivers and also the conflict between people who don't ride EV, and also there are various different kinds of conflict caused because of the charging. Most representative thing is that people who drive EV, they'd like to charge first, and then after charging, they don't vacate the space. Then the next person would like to charge their cars, cannot charge. So there could be some conflict. And in the process of charging, there could be various issues. For example, right after charging their cars, and then they need to settle the bill, but sometimes this process is not done in a facilitated manner. So that's where the conflict comes from. What I have written here is some of the articles. So charging conflict can occur in various ways, and in the reality, there are various kinds of conflict that can happen. As time goes by, the drivers of the EV, the users of the EV, they are faced with numerous difficulties. Once again, here the keywords are charging conflict, lack of charging infrastructure. No matter how much we build charging stations, still we suffer from lack of charging stations. And although we have a limited number of the charging infrastructure or charging station, maintenance is quite tricky. So to prepare for the expansions of the EV drivers, we need to find a way to provide enough infrastructure. At the same time, we need to provide sufficient charging infrastructure, but also various kinds of EV charging related services needs to be provided, and we believe the service platform can be the answer. As we build service platform, not only charging of the EV can be possible, but also an ecosystem can be built. So when the platform service is provided, EV zone platform solution for building and managing charging infrastructure ecosystem, it will be possible. Next, in relations with the platform, let me touch upon the EV charging speed. When I say slow charging, that means charging is done at the speed of 7 kilowatt or less per hour. Why am I talking about this slow charging? Why should we have a charging station that provides slow charging? Why? Let me tell you the reason. As I mentioned before, most of Korea, the population have the residence, which is an apartment complex, and the population density is huge, and charging infrastructure must be built considering that people live in the apartment. The speed of the charging at home or at residential area should be done in a slow manner, because house or apartment stands for a place where people take a rest. So when they park their car to charge, it needs to be done in a very slow way. Probably they don't want to remove their car from a charging station to another place. That is why a slow charging concept must be established. Currently, the charging facilities are around 5%. It actually increased from 1%, but compared to the total number of the people who drive EV, still charging station is insufficient. So whether it's housing areas or company, the workplace areas, we need more charging stations. And definitely slow charging station is much cost effective. If it's a fast charging, it requires a lot of electricity and it's quite expensive. But slow charging means it is charged at a very slow manner, so it's very economically viable. Once you park, you don't have to remove your car to another place. So, considering the life pattern of each individual, infrastructure needs to be enhanced. And if you visit apartment complex, you want to build a charging infrastructure, but because of the limitations of the electricity transmissions or distribution, you cannot build it. But there are more people driving EV, and charging station must be built, but we don't have enough spaces. Or we need to increase the systems to charge. And sometimes if we have to replace the transformer, then the cost will be too expensive. Who will bear the cost of replacing or reinstalling transformer? So once again, EV will not be expanded widely. So I believe that the keyword should be here. Maybe the practicality of low-speed charging for electric vehicle can be our keywords. Below, you can see the comparison between slow charging to the rapid or fast charging. In case of the slow charging, it is done in an AC, but in case of fast charging, it is done in a DC. Of course, there are pros and cons, but I just want to point out a couple of things. Slow charging, the battery will not be heavily burdened with their speed itself. So most of the EV makers recommend strongly the slow charging. And it's very simple to install slow charging facilities. So it's economically viable. And the parts or components, replacing that is quite easy to do so. And also, the charging electricity cannot be that much limited, which means that we don't have to give a huge burden on the grid network itself. Next, let me tell you about the current status of the EV charging station deployment. I've done some research of the charging station in foreign countries. Until 2030, private charging stations are expected to account for 90% of all charging stations in all scenarios. Here, private charging stations account for 90%. This is critical because the role of public charging station will be further decreased. And definitely, EV will increase. And the mass productions of the EV is on the rise. And there's no doubt that the EV will constantly be on the rise. There's one more thing. In considerations of the electric power system reorganizations as an electric vehicle introduction leads to increase in peak power and transition network capacity, I believe the KEPCO is also talking about this. But the electricity system to provide more electricity to EV, well, we need to remap the system itself. Now's the time to do that. And this is quite amazing number, but the market size of the slow charging infrastructure is likely to be expanded on an annual basis of 688% up until 2027. That was the foreign slow charging deployment status. Let's go into domestic slow charging deployment status. As I mentioned before, there's a mismatch occurs between the location where the charging infrastructure is installed, and more than 70% of the housing complex in the metropolitan area is comprised of the apartment, and charging infrastructure should not focus on the number or quantity, but we need to install charging stations at a place where there's huge traffic of the people. So not quantity, but quality-wise, we need to expand the charging facilities. And there are a lot of charging facility in Korea, but still, never once charging stations were used in some of the places, which means that there are some blind spots. And in order to use this charging station, they must go to a place where there are a lot of multi-housing complex or workplaces, but you can hardly find the charging station. And most of the charging stations sometimes are established in an area where people don't go there at all. Those are really blind spots. Just like the foreign deployment status, once again, around 650% of the growth is expected to be realized in the slow infrastructure facilities. So by 2025, the market size will be expanded by about 650%. Jeju Island is no exception. If you look at the current status of the electric vehicle charging infrastructure, you can see that reaching the limit of the building charging infrastructure due to the space constraint is huge. And out of the total number of the charging stations, 75% is actually personal charger. Personal charger means like it's not a public. So personal means like anybody, private charging station, not public charging station. About 75% of the total, out of the total charging stations, so around 20,000 charging stations. Out of that, 15,000 are established and operated by private entity. So once again, you can see that very few are built by the public entity. And still, because there are less than 10,000 public charging stations, people who drive EVs still suffer from the insufficient charging facilities. And because of that, even if we want to install more charging stations, we cannot add more because of the space limitation or because of the blind spots, and expanding it is quite difficult. So on the left, I have written down here, this is my proposal. We need to build a charging infrastructure based on the sharing economy, where you share what you own and I borrow what I need. That should be the concept. So if we build infrastructure for the charging station, instead of building new things, we can always share. And this I call as a charging infrastructure sharing platform to increase usability. We got approval from the Ministry of SMEs and Startups, and we started doing this in Jeju Island. And private charging infrastructures are now being used and operated and managed by entrusted parties in the concept of the sharing economy. So once again, the charging station owned or operated by each individual are now shared by other individual. And then of course, if you borrow that charging facilities, you need to pay the price. But still in the area of the EV charging infrastructure, never once I have ever seen any kind of the sharing economic model. That is why I have written here that this platform, sharing platform, is the world's first one. And I sincerely hope that more charging facility can be shared. And if we do that, definitely the conflict between the EV drivers can be decreased, especially the charging stations that are built by the private parties can be shared. And even if they'd like to use it, still they don't have money to build a private charging station. Then by sharing the charging station, we are considering the other people. So charging infrastructure will be managed in a very healthy manner. From now on, there are 5 slides I'd like to share with you. And these 5 slides are the actual data that we have gathered from Jeju Island. On the left, you can see that 2020, from January to December, we have done this analysis. As we share more and more, it increases. What I mean by that is the network effect or innovation that improves the number of the participants increase. Because EV is so expensive, the people who can afford to buy EV are regarded as affluent people. And those who drive EV are not young people, but the economically active people who are senior people. But they are not familiar with the concept of the sharing economy concept. Some of them even reject the idea. So it was hard to persuade them. But during the time that I don't use my own charging station, we persuaded them that you can let other people use your own charging station and you can earn extra money. So the time that you don't use this, definitely you can let other people charge their EV at your charging station. As a result of that, more charging station it is used and more people uses EV charging station, there were greater rewards. That's the meaning of this chart. One additional point I'd like to make is that, well, private charging station is not a target under the law to be managed or operated. So post-management or post-operations or these kind of laws and regulations are not applicable to the private charging station. But when the owner of the private charging station let other people to use their own charging stations, then they are exempted from the operations and the maintenance cost. So it provides a great benefit. Now let's go to the problem-solving cases. Economies of scale will definitely give a great benefit to the owner of the charging infrastructure. So this shows the trend analysis of the electric vehicle charging usage in downtown area. You can see that a lot of EV charging stations are built around Jeju Island. Jeju Airport. Of course, in certain area, some of the charging stations were established. And when I say established, it means that people shared to use or let other people use his or her own private charging station. So the conclusion is simple. We need to build a charging station where there are a lot of passerbys or a lot of traffic traffic occurs a lot. So this is the main important point. This model itself, when we introduced to Korea, especially implement that in the metropolitan city area, then we can accumulate more data. We can see a greater amount of model. Now, people who let other people to use his or her own charging station, we try to analyze the usage trend of the light and medium load time period. And usually they come home after their work right before they go to bed. They start charging their car so that they can drive their car on the following day. So these are the time that when the charging fee is the lowest. And also these are the time that various usage pattern exists, but most of the time, people charge up their cars. On a seasonal basis, we don't have much data to analyze and compare that. But the greatest benefit is that right after they come home, they start charging their car, and then they stop charging their car when they go to work on the following day. These are their life pattern. This data shows, depending on your location or space of charging, in the beginning, usage patterns vary depending on the installation locations and owner's environment. But as more and more people use this charging station together, because in the beginning there were people who live in the apartment complex, some in villa, or sometimes some of them live in the pensions or different kinds of the houses. The orange color bar shows the outsiders who come and rent this charging station. So we found out that if you share your own charging station, some of the people visit your home or your place and then ask for the usage of the charging stations. And after they use that, they pay the money. And as more people come to share the charging station, then those who borrow can enjoy the benefit, but also who lend their charging station can also earn extra money. This is great. And then lastly, that I'd like to share with you is safety accident classification criteria that we have gathered the information from the traffic control. We have analyzed the complaints raised by the citizens, and it shows a similar trend with that of the individual people. They want to know how can they register that they'd like to usage the privately owned charging stations, and what happens if it's broken. Of course, not a single charging stations were broken down, but from the simplistically put of the charging stations were in the main interest of a lot of people. For your interest, we do provide a charging station, but we also provide maintenance and operations of the charging station. So we are a platform provider. And also personal charger sharing case, I would like to share with you a couple of photos. In Jeju Island, individual parking space is a concept that is unfamiliar with. They believe that even if they build a charging station, it is for themselves, and opening those charging stations and letting other people to use that was sometimes difficult to do so, but now it's being done. So let me put it this way. I have my own charging facility, but I use once or twice a week to charge my car. But there are times that I don't use my charging station. But if I let other people to use my charging stations and let them use my parking space, then I can earn extra money. And then using this money, I can charge up my own car. So these are the basic concept. Currently, this is being operated.
다음은 그 다른
Next, I'd like to share with you a different case. And we are a platform provider, meaning that we just install charging station and we operate it and we receive payment. That's not what we do. We efficiently and effectively operate electricity, so energy management system or EMS linkage and power database customized service is important for us when we provide urban slow charging solution. Inside an office or an office building, the number of the installation is limited, and there are not a single apartment buildings or office building that consider building the charging station from the very beginning. So we need to come up with an idea how we can effectively let people come and then charge their cars. This is how we started our EMS energy management system. We have many scenarios, but there are scenarios that are actually being implemented, or some are in the process of preparation. Let me touch that one by one. Essentially, the power control, the aim of the intelligent electric vehicle charging system scenario is to control power for charging electric vehicle, appropriate power distribution for existing use. The first one is AMI-linked remote power control and power distribution service scenario. And the priority of using this charging station to whom should we go? Because the electricity capacity for the charging station, how much it is. For example, during the summertime, the air conditions were used too much, so the apartment or the building complex cannot provide extra energy. So this is what it meant by. And secondly, then it's not a one single EV, but what if many EVs come and they'd like to charge their cars? Then how can they distribute electricity? For example, the buildings or the housing owners, they can determine who should become the first user of the electricity. If you want to pay extra money to use the charging station, probably you should allow them to pay extra money and then use the charging station. Second, I'd like to share with you the scenario is the service point of view. We can utilize incentive and penalty as well. So just like the previous case where the remote power control and power distribution service can work, at home or offices, we provide electricity and we are checking whether the buildings are providing electricity in a peak way. Then the building will charge first and then EV will charge up later on. Then I can use the charging facility later on. There could be some delay, and then these people who tolerate it will get paid the incentive. And third, we can use the EV battery as ESS, and then we can resend the leftover electricity back to the apartment. So this is like reselling concept. The actual case, let me tell you, is in H apartment in Yongin City in Gyeonggi Province. This is for your reference. And also, in case of IBK, which is bank, for the first time in Korea, they have connected it. And then for the first time, EMS-based EV charging platform services are built and are now being used. I believe that there will be more cases of EMB-based EV charging platform service application case will be done, because we have no options but go to the directions of using EV. And if we can connect that to the operations of the building itself, they will be very helpful to those who would like to use the charging facility. I have mentioned to you about the electric vehicle charging service-based energy platform, and this picture shows the gist that I have mentioned so far. Due to the limited time, I will skip this. As I mentioned before, this is a different model, but in reality, when the EV is charged and then EV is driven on the road, electricity, what if the EV is not environmental friendly? Then can we call the EV as an environmental friendly EV? So those questions were raised many times. And what I want to tell you is that using the renewable energy, we can store ample or excessive energy, and then during the nighttime or during the time that nobody uses their charging stations, they can use this. As I mentioned before, total energy solution platform utilizing the distributed energy is how it looks like. Last but not least, the content I'd like to introduce is that when we use energy battery system, it's not that I use it but for my own car, but rather to the third party, whoever needs electricity, how can we provide service to them? Well, we call this as a V2L, vehicle to load service. So I sell the energy that should be gone to my car, but I don't use it, so I can sell that. That's the concept of V2E. That concludes my presentation. Thank you. So slow charging based solutions and platform provide all the content given by Chairman Kim Hyun-jun. So because of the charging facility, there's another important factor, which is the fast EV charging.
펌킨
Now, CEO Choi Yong-gil of Pumpkin will be making the next presentation. Please welcome him with a big hand. Hello, I'm Choi Yong-gil from Pumpkin. And allow me to take my mask off. Today, I'll talk about the system cases and the cases that we are working on. And if you haven't heard about Pumpkin before, well, Pumpkin stands for literally the pumpkin, and friction, electric power, was manipulated by a philosopher called Thales, and that was the starting point of electricity, and that's where we got our name. So low charging or other charging, we have similar but unique services of our own. And let me go over today's contents. As of May this year, for taxi, logistics, and bus, we have launched a charging brand, eBOP. eBOP, BOP stands for Rise in Korea. So for all types of e-mobility that our customers want to charge, we have created eBOP brand. And for the brand, let me talk about our models that actually create profits. And this is the biggest contributor to our sales, taxi and bus. More than 70% of taxis in Korea, or more than 2,000 buses, we charge them. And we create more than 30 billion won of revenue, but just by charging the buses. And Easy Charger or charging speaker have talked about the charging, and we have developed the bi-directional platform for 5 years. And then eBOP is Korea's #1 company in the construction and operation of large-scale charging infrastructure. And having a bi-directional control to support the cost of transportation would be important. And we have created a forceful system. Even if the driver makes a mistake, we'll be able to reduce the electric bill. And we have 1,700 170 megawatt electricity charging stations, and we charge about 250 gigawatt per year. And to us, 200 to 250 is the smallest charging capacity for us. And we care a lot about renewable energy and ESS. But currently, we do not have the economically feasible model for doing that based on renewable energy. We haven't been able to commercialize renewable energy yet. The biggest challenge for large-scale charging infrastructure is that the driver plugs in to the charging infrastructure, bus or taxi, when they drive backwards for charging. This creates a lot of problems. And in order to resolve that problem, we have been working closely with Hyundai Motors, and I will show you a video of our development. This system is fully automated, and the bus and the charging system, Wi-Fi, AI technologies are used in an automatic manner. One pantograph can support 4 units. This is charging with one pantograph And we can scale this up to 1 megawatt. 30 minutes for 80% charging. This system is available for autonomous driving vehicles, e-bus, and we are reviewing this technology for introduction. In June of this year, for the first time in Korea, in Busan, this is how we are going to install this. This is the system structure. Bus, pantograph, through AI, technology will communicate wirelessly, and when it finds the position, pantograph will drop down, fast to charge, and this will move around the vehicle that needs charging. We developed this for 3 years. We have all the IPs for fundamental technology, and it is now being used to, the vehicle is now being developed by Hyundai Motors. And this picture, as of the end of June, we'll go into first test in Busan area, and after verifying this, we will start commercializing next year. And this is our main focus, these areas, electric trucks and taxis. And large logistics station, last mile charging stations are all needed. In designing the system, each garage, we have to consider the limited space and the large last mile charging systems design and deployment is really important. We have deployed up to 1,000 to 9,000 kilometers. So we focus on large-scale fleet-based charging system. And we are the only company that's developing this, charging the heavy construction machines. And we are developing charging machine for 20 to 300 gigawatt. And we are going to test this in the second half of this year, and it is going to be commercialized next year. And electric taxis, beginning this year, the gas and the diesel price has gone up. They have gone up by 60% year on year. All the taxi companies are complaining heavily about this increase in fuel price. They have to really switch to electricity to survive. And we have been selected as a charging vendor for electric taxis by the Seoul Metropolitan Government. And we have signed with the largest taxi fleet company in Korea to provide charging capacity for their taxis. This system includes a variety of fast charging system. This is for brief charging, and they need to charge while they have a short break. So there is a need for fast charger. There is no room for slow charger. And we have developed our own AS system, customized it, and then we are introducing the training portion, training services as well. Since last year, we have been working on this project. E-mobility is more than just trucks and taxis. At the end of this year, we are going to have electric airplanes. So since last year, Pumpkin has been working on mobile charging station that can operate on the runways for the airplanes. Last year, as you can see, for runways and silos, we have installed them. And beginning this year, we are making this mobile so that it can go to the airplane on the runway. On the left-hand side, this is energy-independent mobile rapid charger. Right-hand side shows shelter installation. And then I will talk about ESS independent fast charger. All large-scale charging stations, the most important part is to continuously supply the energy and also reduce the cost of energy. As for reducing the energy consumption, it would be bidirectional AI control to minimize the electricity bill. And there are some stations that uses up to 100% for light load. Some trade stations and 90% for light load, 10% for medium load. We have great optimization system. Last month, we have been selected as a ESS supplier that provides fast charger, wireless charger at the same time. And when this project progresses, we'll be able to reduce energy consumption and stabilize the electricity supply. And for ESS, because there was a strong demand from our customers, we have thoroughly reviewed this business model. Pumpkin, our smallest station is around 1,000. Our largest station is up to 9,000. So up until now, we have tried to reduce ESS and spent battery, but the economic feasibility was almost non-existent. So we tried this last year, but we tried to put this on hold because of lack of economic feasibility. Let me talk about power sharing. It's a common challenge for all charging businesses. We are concerned about 1 megabyte. How many cars we can charge, how fast, at what output. This is our major area of interest, and we have continuously been developing products since 3 years ago. So speakers from Charging and Easy Charger have talked about various types of chargers: fast speed, automatic charging, slow charging. And we are integrating all of those charging systems for smart cities, from personal station, ESS, V2G, station-based solution, and ESS can reduce energy consumption integrated with DR project. When this picture can be realized, we will have a great energy charging infrastructure that is appropriate for a new town. And with the large corporations, we have designed this personal mobility convergence platform, autonomous charging, autonomous driving vehicles. We are going to provide this future gas station convergence charging infrastructure. And for EVs and non-EVs, we have to think about how to utilize the parking space. And the Ministry of Commerce and Industry has revised the relevant law, but they are not effective. 3 years ago, we have certified our fast charging system, and we are providing them in Seoul now. The solution here is that to promote rotation of charging space for EVs. And we have patent over parking cost application and billing. When there is a similar product, we are going to strongly argue with that using the legal instrument because we have the fundamental IP rights. This is something that we have been working on for the past 3 years. It's a premium charging system. Up until now, all the stakeholders were looking for the cheapest solution. They did not care about the design or the function. But over the past 3 years, we have developed the best premium charging system called Moon Series, and it would have all the functions available for charging system. And in terms of design and function, they would have secure function. And Pumpkin's biggest advantage is that all this platform, OCPP, integrated control, it's something that we have developed and operating on our own. Ministry of Science and Technology has selected us so that through charging data, we can create other monetization models. And one of them is DR, demand response business. I think we are the only charging company that has been successful with DR business. For other vendors, it's not a profit-making part of their business. But since last year, we have been certified by the Ministry of Power Exchange, and we are creating monthly profit. But in 3 years, its profit will go up to 100 million per month. And by reducing the power real time, we'll be able to create profits. We have been working with Encode for 5 years, constantly refining our business models. This is OnTech. Everybody wants PNC-based charging, where they can make automatic payment and automatic charging at the same time. We will continue to focus on faster charging. And for commercial vehicles, the lowest battery is 29, so it would take more than 10 hours to be charged, which is too long. For faster charging, taxi, bus, logistics fleet, and other large-scale electric vessels, that's our area of specialty. Thanks to all the support that we have been receiving, the bidirectional V2G, we have been selected along with CRISO. So next year, we will also be able to work on the fast charger for electric vessels. And after establishing Pumpkin, we have tried to differentiate ourselves in terms of our product and services. And whenever we are working with domestic or overseas partners, these are the focus areas because they are our core businesses. Fortunately, the speaker from Easy Charger or Charging, we are not direct competitors. For slow charging, we are going to collaborate with others instead of doing it our own. We are going to focus on faster charging and automatic charging for our product and service development. So I think we'll be able to complement each other through collaboration. And last but not least, for EBOP, the brand, we have created a song because I happen to know a composer, so we created the song and also created the lyrics to promote our brand.
환경, 에너지, 그리고 사람. 펌프킨과 이밥이 만들어가는 깨끗한 세상.
Clean world created by Pumpkin and EBOP.
저 화석화된 광물 호박을 마찰하면 생겨 전기라는 선물 우린 이제 그걸 만들어 친환경 에너지는 내가 전문 보석으로 쓰였던 호박 우리에겐 익숙한 호박 넌쿨 그래서 결국 이름 지어 펌프킨 앞으로 전기 분야 우리가 선두지 계속해서 늘어나는 거리의 전기차 이 많은 차 충전하러 어디가 펌프킨을 구축하지 인프라 전기차는 밥을 먹어 기쁘다 그래 우리가 줄게 이 밥 금방 충전돼버리지 이 밥 일단 전기버스 충전부터 시작 곧 차려진다 밥상 펌프킨이니까 펌프킨 이밥 펌프킨 이밥 우리가 만들어 스마트 시티 펌프킨 이밥 펌프킨 이밥 우리에게 맡겨 이 모빌리티 펌프킨 이밥 펌프킨 이밥 우리가 만들어 스마트 시티 펌프킨 이밥 펌프킨 이밥 우리에게 맡겨 이 모빌리티 엄마가 해주던 밥 이밥 세상 모든 부부기는 먹고 가 이밥 친환경이야 시간 지나야 진가가 빛나 펌프킨 이밥 엄마가 해주던 밥 이밥 세상 모든 부부기는 먹고 가 이밥 친환경이야 시간 지나야 진가가 빛나 펌프킨 이밥
예, 이상으로
That's the end of my presentation. Pumpkin, we haven't received any investment so far. And I think we have a unique, all the products from Pumpkin will be launched under EBA brand and automatic charging system. We're going to introduce a great products in the market. Thank you. Fast charging system. I think you have developed a very effective model for growing the business. And now it's 5:25. So why don't we have a 5-minute break? And then we will have a Q&A for 20 minutes. And then I will also ask questions to the panelists. So 5-minute break. See you soon.
안녕하십니까. 지금 현재 우리 제6회 글로벌 EV 라운드테이블 두 번째 세션의 마지막
Now, as the last session of this EV roundtable, we are going to have the panel discussion, and as a moderator, I'll talk about low speed, fast speed charging, and I have question to the people from the business community. The electricity supply and demand will change around the world as the renewable energy portion goes up. The nighttime electricity bill will go down and the daytime electricity bill will go up. And everybody expects that to happen.
그리고 그 신재생 에너지의 발전량이
And as the renewable energy portion goes up, it is going to be the given direction in the future. And those who are developing low charger and fast charger, in the case of new future, we have to think about what would be the business model, the best response. I have a question to Mr. Shin-Gyushik, Dr. Shin-Gyushik from Easy Charger. Hello, I'm Shin-Gyushik from Easy Charger. And our perspective is slightly different from your question. As a charging company, it's not a matter of whether electricity is expensive or cheap. Because in Korea, 70% of the people live in apartment complexes. And because of that, car parking is becoming an important issue. It's not a matter of how expensive or cheap the electricity is. The parking is the biggest challenge. So the best option is to charge it while the park is where the car is parked. %70 of EV users drive less than 100 kilometers per day. So for these people, we need to resolve and the problems they are most likely to face. So for charging business owners, we are not so sensitive to electricity price. Thank you. As for the next question, Mr. Kim Hyun-jun, Chairman of Charzin, can I ask you the same question? I'm Kim Hyun-jun from Charzin. When the renewable energy portion goes up, it boils down to the question of where the energy will be stored. Currently, we have 200,000 units of EVs in Korea, and around the world, EV will increase rapidly in number. Everybody believes in that kind of trend. For EVs, 60 to 70 kilowatts per hour battery capacity. All of them have to be utilized as ESS. And when the renewable energy portion goes up in energy supply, we can keep them stored in EV batteries, and when the electricity gets more expensive at night, we can provide that energy back to the grid. I have talked about a similar case in my presentation. Wherever there is a need for electricity, we can forecast that kind of demand and then provide wherever there is demand for electricity. And we are going to be geared towards such services. And during the day, probably there is a need to collect EVs together, and the owners of the EVs needs to be provided with rewards or incentives for sharing their electricity. So it sounds like as if money should be involved, but storing energy is going to be the best way to save energy. So that is the direction for our service deployment. Thank you.
얘는
In my view, well, as Chairman Kim Hyun-ju and Dr. Shin Kyu-sik talked about, those were quite interesting things. Especially Dr. Shin Kyu-sik focused on the fact that most of the residential configuration is an apartment complex. So how can we use electricity at the lowest possible cost within the structure of the apartment? And one of the main points is that during the daytime, how can we accumulate electricity at the place that we work, like workplaces, like office building, right after we go to the work, we park our car for a long time. And during the time, how can we store our energy into the EV, and probably the charging station can play that role? I'd like to ask the same questions to Pumpkin CEO Choi Yong-gil, who mostly use the fast EV charging business in your business, especially focusing on the fleet services for the fast EV charging business. So CEO Choi Yong-gil, I'd like to ask the same question.
예, 안녕하세요.
Hello, I'm Choi Yong-gil from Pumpkin. Professor Choi, as he mentioned, if the electricity bill goes up during the day and goes down during the night, then our business model needs to make a lot of change, because our monthly bill for large scale, basic fee plus usage, bill per usage, that's how we bill our customers. So we have the basic fee plus fee per usage. During the day, if the electricity bill goes down and everybody wants to do faster charging during the day, then per station, we need to reduce the charging time so that more maximum number of EVs can be charged. So we really have to go for cutting down the time for charging. So we need to add more charging equipment. And we also need ESS portion of charging, and that market will be created. And last but not least, those who have large fleet charging system, their operation cost needs to go down. So there should be a program that naturally moves toward cheaper electricity. And for renewable energy, because of the ESS fire, the distribution is rather slow. But if we can develop fireproof materials, then I'm sure ESS market, along with the charging infrastructure, will grow.
대단히 감사합니다.
Thank you for the great comment. From the perspective of fast EV charging business, when electricity bills fluctuate, I believe that your answer really resolved the concerns that we have. One of the concerns that I always have is, from the perspective of fast EV charging, we use a lot of electricity in short period of time. Will that give a huge burden on the grid network? Do you have actual cases? some of the time, if it was too burdensome, how do you react? So any answers probably from Pumpkin?
As the moderator has mentioned, and EV distribution rate in Korea is less than 5%. And because of that, when you apply for KEPCO, and then when you try to receive low pressure or high pressure electricity, there has been no major issue for our company so far. Of course, there were some issues when a large-scale apartment complex tried to get the electricity supply. But so far, we haven't had any major problem. But as the professor has mentioned, if the electricity billing system changes with an increasing portion of renewable energy, then the power supply itself could present new challenges. And when the EV portion or share goes up to 40%, then electric bus, 2,000 units of bus use 250 gigawatt. But when it goes up to 30,000 electricity, it's going to use 2,500 gigawatts. It's huge amount of power. And they have a fixed amount of electricity they will use per day. So for the entire city, if the taxi is 50% and 60% of bus becomes electrified, then we need to have a total estimation of electricity demand and talk to KEPCO with that number. Otherwise, there could be a situation where charging would not be done because of lack of electricity supply. So in line with such probability in the market, we have to start creating the business model for that. Thank you for the wonderful answer. And you have talked about decentralized energy, which is renewable energy. And to use this in the efficient manner, we need energy storage system. And up until now, we have carried out some pilot projects with ESS, but they have created some problems. So that has actually dissipated the trust in ESS. But there can be no decentralized energy system without ESS. And Mr. Shin Kyu-sik from Easy Charger and Mr. Kim Hyun-jung from Charging, you have talked about how the low-speed charger can store the energy. And Mr. Choi Yong-gil from Pumpkin, in operating high-speed charger, you said that ESS is essential. In that regard, decentralized energy structure and ESS, for that would be most critical. So for such safe ESS, do you think there is sufficient demand for such safe ESS in the market? What's your opinion about that? Dr. Shin, would you like to tackle the question? Yes, when it comes to ESS, there is a great room for improvement. And V2G, we are carrying out a lot of demonstration tests. And battery functions, I know many people are concerned about battery functions. And at the national level, such things are that must be improved, and they will play an important role for decentralized power structure. V2G ESS will continue to evolve, and many people will take part. Mr. Kim, what's your opinion? I have a similar opinion. ESS, when there is a fire or any problem, we shouldn't stop developing ESS technology. EV batteries, the spent batteries will be produced, and how we are going to recycle them for ESS batteries is something that we need to focus on. Renewable energy, when you look at the trend, it's kind of irreversible. Currently, we are doing the charging business, but with time, renewable energy will be the source of energy, and energy will be storage. And that energy will be sent. We need to consider all these types of energy. Thank you very much. In that regard, President Choi Yong-gil, would you like to make a comment? And thank you very much. And I have been thinking about this. And the people who are doing ESS, PV, developing new materials for EVs, and people who are developing technologies for recycling spent batteries. When the renewable energy takes an important role in providing the energy, I'm sure that we need to work together with a variety of companies in variety of industries. Thank you very much. Thank you very much. Not just in Korea, but around the world, EVs are becoming the massive force. And developing the charging infrastructure is most critical. Producing electricity is not easy.
So dependency on the renewable energy will be on the rise, that is for sure. But we need to come up with a way to utilize distributed energy. For that, ESS must be further developed, and I believe that we have reached a consensus, whether it's a fast charging or whether it's a slow charging, whatever road we take, we need to make sure that fundamentally we use electricity. So based on the renewable energy, we need to make sure that we make most of the ESS, and then on top of that, we need to make sure that everyone can enjoy the distributed energy. Well, for the past 2 days, we had the 6th Global EV Roundtable, and it's a time to conclude the session. For the past 2 days, yesterday and today, we have addressed the shipbuildings, the maritime industry, sales structure, and charging stations and charging infrastructure. And also, I believe that we're able to give great information. Thank you so much for your attendance. And I believe that we have been able to address many issues. Thank you so much once again. That concludes the 6th EV Global Roundtable. Thank you.
수고하셨습니다.